Hi, this is Bankar Nagraj, Assistant Professor, Department of ME, B.Ed Ballari. So, in the previous class, we discussed about reliability concepts. So, what is reliability? What are the parameters or the terminologies comes under reliability? So, now we will discuss about some more topics in the same module, second module. Before discussing some points, we need to know some parameters and their meanings. So, what is guarantee? Whenever you need to buy some things, electronics or some other things, whenever you need to buy, so they will give some shops will give guarantee. Some showrooms will give some guarantee. What do you mean by guarantee? That is an assurance given by the manufacturer to the vendor that the product will work out, will work without failure for a stated period of time. The guarantee is only an assurance. Then what is warranty? A return guarantee given to the purchaser of a new appliance, automobile or other item by the manufacturer or dealer, usually specifying that the manufacturer will make any repairs or replace defective parts free of charge for a stated period of time. I think now you got a point or clear picture what is difference between guarantee and warranty. So guarantee is only an assurance. Warranty is a written guarantee. So whenever the damage happens, whenever the fail of equipment occurs, they will replace or repair the defective parts with free of charge within a stated period of time. 3 years warranty, 2 years warranty. That is the thing. What is guarantee and warranty defines. Now we have one more term called maintainability. The measure of ability of an item to be retained in or retained to a, or restored to a specific condition when maintenance is performed by personnel having specified skill levels using prescribed procedures and resources. Maintainability is a measure of ability of an item to be retained or restored. The item should be restored whenever the maintenance action took place for a specific item that should be available. Availability. A tool for measuring the percent of time an item or system is in a state of readiness where it is operable and can be committed to use when called upon. Maintainability is the ability of an item to be retained the same condition. Availability will be is a tool for measuring the percent of time when it is going to get ready, when it is going to available, what is the downtime, what is the uh, maintenance time, what is the repair time. So when it is going to available, that is availability, percentage of time. Reliability, we discussed the reliability definition in the previous class. The ability of an item to perform a required function under stated conditions for a stated period of time. Not all the equipments have the same ability to perform the required function under stated conditions for a stated period of time. It is usually denoted as probability or a success. So now we have five different terms: guarantee, warranty, maintainability, availability, and reliability. You need to know the differences of all these. So now we have whenever it comes to the probability, we have three different terms that should be remembered is R, mean, median, mode. So look at the graph below. We have a mode, median, and mean. So then what is mean? The sample mean can be used to estimate the propulsion mean, which is the average of all possible outcome. Mean is average. You know that mean of all this. So you will add all the components and divide by the number of components. Mean, that is what the average of all the possible outcomes is mean. Median, it is a measure of the central tendency, median center, which is a midpoint of the distribution. It is a point at which half the measured values fall to either side. Mean is the average, median is the center point. Mode, it is a value at which the distribution peaks. So distribution where it reaches a peak, that point is called mode. So now we got a difference between mean is an average, median is the off center point, Mode is the point or the value at which the distribution is reaches peak. So now we have a figure below that table. F of x on the x-axis, on the y-axis, and on the x-axis is an x. Reliability is classified into many categories. Look at this. Reliability is mathematical reliability. What is reliability? You need to know the definition, clear definition. The ability to perform a required function in a stipulated period of time in a under stated condition. So that reliability can be measured with mathematical analysis, system analysis also. So we have many methods to measure mathematically. So they are parametric analysis, continuous data, non-parametric analysis, discrete data, Monte Carlo simulation. I think you would have heard about this Monte Carlo simulation. So from all these three methods we can measure the reliability mathematically. Now parametric analysis we have in the regression analysis, variable distribution, normal distribution, log normal distribution, exponential distribution, regression coefficient, regression analysis. We are going to find out the values, coefficient, variable. These variable distribution, normal, log normal, exponential distributions are the probability of distributions. Non-parametric analysis, median ranking method, ungrouped data, rank adjustment method, censored ungrouped data, complete grouped data, censored grouped data. So system analysis, again we have reliability block diagrams, reliability block RBD, reliability block diagrams or series parallel combination of both. And again we have a fault tree analysis. We will discuss about event sequence diagram. We will discuss in detail about RBD, reliability block diagram, fault tree analysis, event sequence diagram. So again we have accelerated life testing. Look at again in a parametric analysis we have most likelihood analysis, MLE, time terminated, failure terminated, with replacement, without replacement. And this is a chart of reliability, mathematical analysis, system analysis, parametric, non-parametric, Monte Carlo situation, reliability plot diagrams, fault tree analysis, most likelihood analysis, regression analysis, nothing but possible distributions. So look at this table. We have 6 types of these are the 3 types, and again we have three more types here. These are the what types of distributions. This module name is reliability and probability concepts. We have a probability distributions. Look at this type of distribution is normal, parameter is mean, mu, standard deviation, sigma. Probability density function f of t. When the type of distribution is normal and the probability density function f of t can be drawn as this curve, and f of t probability density function is having a formula f of t is equal to 1 by sigma 2x to the power 1 by lambda 1 by mu e to the power minus t minus mu whole square divided by 2 sigma square. This is a formula to find out probability density function f of t in normal distribution curves. Reliability, probability density function for the same type of distribution. What is the reliability function? R of t. R of t is always 1 minus f of t, and the curve will be like the second curve. The third for the normal distribution, adjourned function, instantaneous failure rate, f of h of t is equal to f of t by r of t. So the curve will be like this. The third one last. So type of distribution is normal distribution. Table is much used in many industries to find out the probabilities, reliabilities, and adjourned function rate. So next we have one more is log normal. Second is log normal, standard deviation, sigma, mean, mu. These are the curves f of t, probability density function f of t is equal to 1 by sigma t to 2x 2 pi to the power 1 by mu e to the power minus ln t minus mu whole square divided by 2 sigma square. The same kind reliability function R of t is equal to 1 to the t to the power in t to infinity f of t dt, h of t is equal to f of t by r of t. So exponential distribution, normal distribution. I think you have heard about the types of distributions. Normal distribution, exponential distribution are the major type of distributions we have learned. Failure rate lambda exponential MTBF. What is MTBF? Mean time between failure, theta. So these are the types of curves you can get for probability, reliability, and agile rate functions. So look at the formulas also in exponential distribution to find out f of t, r of t, and h of t. So next three we have a gamma distribution, variable distribution. Second, next fifth one, sixth one is extreme value type 1, 2, 3 in variable distributions. So now we will go to the gamma distribution, fourth one, failure rate lambda, and you just go through all the curves and formulas of probability, reliability, and agile rate distributions. So variable distribution also normal, exponential, variable distributions we have more, right? We have different types of curves, different formulas to find out the different probability, reliability, and agile rates. For the last, extreme value type 1, 2, 3 is variable. So these are the formulas, and you make it a questions in this probability concept, types of distributions, types of probability distributions. You can write all these parameters and you can write the formulas, write the curves, write the table itself, that is based on the marks. If it is less marks, you can write 3 or 4. If it is having a more marks, you can write all the 6. So reliability block diagram, RBD. Systems are composed of components. Almost all. This is in common. Any system are composed of some components. RBD, reliability block diagram, is a method of evaluating the reliability of the system by the establishing following relationship. In the reliability flowchart, we have discussed about reliability block diagram, fault tree analysis, right? So this is what the one type of method which is going to evaluate the reliability system of the system. Reliability block diagrams. We have 3 kinds of reliability block diagrams: series, parallel, combination of both. These structures helps in understanding logic relationships. Series configuration. So failure of any component in the block will lead to the failure of the entire system is series configuration. So look at the diagram 1, 2, 3, 4 up to n. If any one component fails in the system, entire system is going to get failed. This is what series configuration. And look at R suffix S, RS, system reliability. E1, event where component 1 does not fail. E2, event where component 2 does not fail. R1 is the reliability of the component 1, R2 is the reliability of the component 2. So we have a formula for this system reliability in series, P of E1 into E2. Probability of the component event of component 1 does not fail into event of component 2 does not fail. So then it is multiplied probability of component does not fail, P into E1, P into E2. So then it is written as R1 and R2, PE1, PE2. What is P? What is E? Probability. P is probability, E is event does not fail. Then what is reliability? Reliability is the ability of performing required function in a stipulated period of time under stated condition. If the component does not fails, that is called reliability. So I think you got a point, clear picture. Then PE1 as written as is written as R1, PE2 is written as R2. What is R1? What is R2? R 1 is the reliability of the component 1, R2 is the reliability of the component 2. That reliability is performing a required function in a stipulated period of time in a understated condition. So PE1, E1 is the component does not fail. Probability of component does not fail is nothing but reliability. It is performing its function. Same PE2. So this is the formula for series system configuration. RS is equal to R1 into R2. Therefore, the system reliability must be greater than the individual component reliability. Because we are multiplying, the system reliability will be always greater than the individual component reliability. That is, all components must have high reliability in this configuration. So this is all about system reliability, series reliability configuration. RS is equal to R1 into R2. Same kind we have one more parallel configuration. In a parallel system, all elements must fail for the system to fail. Unlike series configuration, in a series configuration, if any one system or component, if any one component fails, the entire system fails. But here in a parallel configuration, all the components should fail, then only the system fails. Look at how they are arranged in a parallel configuration 1, 2 up to n. It is in parallel condition. The formula is RS is equal to 1 minus of R1, 1 minus of R2. Generalizing the formula, system reliability is equal to 1 minus R of T. Combination of parallel series. You can find this R1, R2, R3, R4, R5. They are connected in parallel and they are connected to R6 in series. So this is what the probability concepts, the terms guarantee, warranty, availability, maintainability, reliability, variable distribution, normal distribution, exponential distribution, the curves, probability density function, reliability f of t, r of t, p of t, r of t, and h of t, Hajal rate function. So now again we discussed about reliability, system reliability, series, parallel, combination of both. So next class we'll do some other topics in the same module and we'll end it. Thank you.